So, question for you with car charges. You can pay 380 euros for a taxi to pick you up and then pay 130 euro for each kilometer of driving. Or you can rent a car for 15 euros for the day and pay for gas, which will be about 13 cents for each kilometer of driving. So, my questions are, which is the better deal? Well, if you'll notice, it's a lot cheaper to get a taxi at the start. It's 380 versus 15. So it's a lot cheaper to go with a taxi, but when you pay per kilometer, it's a lot more to pay with a taxi than it is with a car. So at the start, it seems like a taxi is a good deal, but I think it would depend on how far you plan on traveling. If you plan on traveling just a few kilometers, a taxi is obviously the better option. But if you plan on driving the whole day or outside the city, maybe a car is a better option. My next question is, what factors should you take into account when making your decision? So, as I mentioned before, you should know how far you plan on traveling, whether it's a short distance or a long distance, and even the time. Do you want the car for several hours or do you need it for just a short amount of time? So, you probably should know at what point it makes sense or at what kilometer does it make sense to switch from the taxi to the car. Well, let's check that out. So first, I'm going to write equations that fit these problems. What I need to know is the slope, the gradient, and I need to know the y-intercept, where it crosses the y-axis. The reason I know these are linear graphs or lines is because it's a constant rate of change. The price per kilometer is not changing. It's a euro 30 the entire time. It's not going to increase pay or decrease pay over amount of time. It's a flat rate of 130 per kilometer. This one's a flat rate of 13 cents per kilometer. The initial payment for the taxi is 380, so you must pay 380. Regardless of how far you travel, you have to pay that flat rate. With the car, you have to pay 15 euros regardless of where you travel and how far you travel. So I know that these two values are my y-intercepts, because the x-axis is going to represent the kilometers of driving, and the y-axis is going to represent the price. So when x is 0, so when I've driven 0 kilometers, my y-intercepts or my y-axis is at the point 380 and the point 15. So when I use the equation y equals mx plus c is going to be 380 for the taxi, and c is going to be 15 for the car. The slope is the rate of change, which in this case, it's 130 for every kilometer. So that is my rate of change or my slope. And for the car, it's 13 cents. So every kilometer will be 13 cents. So here's my two equations. This is the taxi option. This is the car option. Here's what x and y represent. I'm now going to graph these two lines, and I'm using Desmos to graph them. So notice the two lines. The red line represents the car, and this green or black line represents the taxi. Notice that the car is less steep than the taxi, which means as the distance increases, the price increases more rapidly for the taxi than it does for the car. So that's why we know at some point the car is going to be the cheaper option. I need to know what point that is. Notice there's this intersection point right here. This intersection point tells us that when the distance is the same, so when the distance is 9.573, for both lines, the price is 16 euros and 24 cents if I round. So this is the point where the distance and the price are the same for both options. Beyond here, you see a change, a drastic change, where the car becomes cheaper, the taxi becomes more expensive. Before that, the taxi is the cheaper option because it's lower on the y-axis, which represents the amount of money you have to pay, and the car is the more expensive option before the point of intersection. So that's where you can see basically the breaking point. So beyond this point, I'd go with the car. Before this point, I'd go with the taxi. And I've explained that here. The taxi is the cheaper option before 9.573 kilometers, but after 9.573 kilometers, the car becomes the better option. And that's how you read two linear graphs and their intersection point, what that means in terms of the context of the problem.